In level 3, we will be solving polynomial inequalities, and the difference between level 3 and level 2 was that in level 2 they were quadratic polynomials, and in level 3 the degrees are greater than 2. So it's really going to be the same steps. You want to make sure you have 0 on one side, and then you want to make sure your expression is in factored form. Looking at this first one, we already have 0 on one side, we already have factored form. So the next step would be to find the zeros. And the zeros of this polynomial are 0 and negative 3. So I put those numbers on a number line, I make sure they go in the right order, and I test regions. So I test a number to the left of negative 3, something lower than negative 3, like negative 4. And if I plug that into factored form, when I plug it in for x, negative 4 is going to be negative. And when I plug negative 4 in right here, negative 4 plus 3 is negative, but when you square it, anything that you square will always come out to be positive. So that second factor comes out positive. And a negative times a positive is always a negative, so we get negative right here. Now I test a number between negative 3 and 0, so maybe negative 1. And plugging negative 1 in for x, that's negative. And again, no matter what number I plug in for x in the second factor, that will always, always, always be positive, because any number that you square is always positive. So we still get negative. And then I test a number in my last region, so something bigger than 0, like positive 1, and when I plug in positive 1 in the front, I get a positive, and when I plug in positive 1 in that second part, I get positive because I always get positive there, and positive times a positive is a positive, so we get a positive here. And now I'm ready to write my answer in interval notation. I go back to the inequality, and the inequality in this case is a less than or equal sign. I want to know if when this function is less than or equal to 0. And so I'm going to choose the intervals where I got the negative signs, where the function is below the x-axis. So my answer is going to be negative infinity. Now, it would go to negative 3, but it actually equals 0, and since I do have the or equal sign, I'm just going to do negative infinity to 0, because that whole region from negative infinity to 0, the function is either negative or equal to 0. And I'm going to do a bracket because at 0, the value of the function is 0. If this inequality sign didn't have the line underneath, it would have looked different. This is what we get. The next example is not in factored form. So we can factor out a greatest common factor in the expression. We can factor out x squared. And we would get x squared minus 25. And we can factor that a little more. This is a difference of squares, x minus 5, x plus 5. And now that I have it fully factored, I can figure out the zeros. And the zeros would be 0, positive 5, and negative 5. So I put them on a number line in order, negative 5, 0, positive 5, and then I test my regions. So something to the left of negative 5 would be negative 6. And if I plug negative 6 into factored form, plugging it in right here, we get negative 6 squared is a positive, because anything squared is positive. Plugging it into the next factor, negative 6 minus 5 is going to be negative, and then negative 6 plus 5 is also negative. So a positive times two negatives comes out to be positive. Now I'm going to test something between negative 5 and 0. So I'm going to test, let's say, negative 2. And when I plug in negative 2 right here, it comes out positive, because that will always be positive. And then when I plug it in right here, negative 2 minus 5 is negative. And plugging in negative 2 right here, negative 2 plus 5 comes out positive. And a 2 positives times a negative comes out negative. And then I test something, so we got negative in this region. I test something between 0 and 5, say I pick 1. And right here, that comes out positive. Right here, that comes out 1 minus 5 is negative. And when I plug in 1 here, I get positive. So that comes out negative. And then I test something in my last region, some number bigger than 5, like 6. And when I plug 6 in here, it's positive. When I plug 6 in here, it's positive. And when I plug 6 in here, it's positive. And so we get positive. Alright, now I go back to my inequality, and my inequality is a greater than symbol this time. So this time I want to know when this function is positive or greater than or equal to 0. And so I'm going to pick the places where I had plus signs. So my answer is going to be, the first plus sign region is negative infinity to negative 5. And since my greater than symbol doesn't have the or equals line underneath it, it actually equals 0 at negative 5, so I use a parenthesis. And then I do union, parenthesis, 5 to infinity. And there we go. In this last problem, we have two functions, f of x and g of x, and we want to determine when their product is greater than 0. So we just multiply them together. X minus 1 is f of x times g of x, which is x plus 3 squared times x minus 5. And we want to know when that's greater than 0. And my new polynomial, which was the product of those two functions, is already in factored form, and I already have 0 on one side, so now I just have to find my zeros. And the zeros are going to be positive 1, negative 3, and positive 5. So I make my number line, 1, oops, just kidding. Make sure your zeros go in order. It's very important or it won't work. Negative 3, then 1, then 5. And we test regions. So I'm going to test something to the left of negative 3, like negative 4. And we get, when we plug in negative 4 right here, we get negative 4 minus 1 is negative. And when we plug it in right here, negative 4 plus 3 is negative, but again, when we square that, it's going to come out to be positive, because any number that you square is positive. So that middle part's always going to be positive. And then plugging it in here, negative 4 minus 5 comes out negative. So if we multiply two negatives times a positive, it comes out positive. And next I'm going to test something between negative 3 and 1. It would be nice and easy to plug in 0 there. So when I plug in 0 here, 0 minus 1 is negative. 0 plus 3 squared is going to be positive, and 0 minus 5 is negative. So we get a positive still. And next I'm going to test something between 1 and 5. And we get like something like 2 maybe. And right here, 2 minus 1 is positive. 2 plus 3 squared is positive, and 2 minus 5 is negative. 2 positives times a negative is going to come out negative. And now I'm going to test something in my last region, something bigger than 5, like 6. And 6 minus 1 is positive. 6 plus 3 squared is positive. 6 minus 5 is also positive. So that last region comes out positive. And then I'm ready to write my answer in interval notation. So this time I have a greater than symbol, so I want to include all the parts where I have positive numbers. But we have to be careful on this one. I can't just say negative infinity to 1 for the region on the left. I can't do that because at negative 3 it actually equals 0. So I have to say parenthesis negative infinity to negative 3, and then a parenthesis because I don't have the or equals line under my inequality, and at negative 3 it equals 0. So then I do a union negative 3 to 1, parenthesis, and then union my last region 5 to infinity.